Okay, so here we go. The topic. This time, last time it was graphing when it's just ax squared plus c, but now there's a bx in there. Okay, whenever you got the bx term in there, a term that's got an x to the first, that means it's a horizontal shift too. Right? We're not going to get into so much the horizontal shift, but we're going to figure out how do you get it in the right place. Right? So graphing a quadratic function that's got both a horizontal, or it's got a horizontal shift and maybe it's got a vertical shift. Okay, so when a quadratic function has an x term, right, meaning an x to the first, then the graph is shifted left or right. So these are examples. It's shifted left or right because it's got this 4x to the 1. Right? This one not shifted left or right because there's not an x to the 1 there. Right? That one's a vertical shift like we did in the homework last night. Okay. So the question is, how do we figure out then where to go with this? So remember that a parabola is like a U. The bottom point on that U is called the vertex. So if we can figure out where the vertex is, then we will have figured out what is the shift, actually up, down, left, or right. Okay, so we have a formula for this. To find the x-coordinate of the vertex, you're going to, starting with a standard form quadratic equation, ax squared plus bx plus c. The a, b, and c are just the numbers in front of the variables. The c is the constant. Use this as the formula to find the x-coordinate. Negative b divided by 2a. Right? Negative b divided by 2a. And then once you know what that value is, you put that value back in for x, and you calculate the y value. Okay, so here's an example of that. Well, first, whenever you look at a quadratic function that's in standard form, meaning that there's highest degree term to the left and then decreasing order of the exponents, the first term, we've already dealt with this. That's going to tell you whether it opens up or down. Does that one open up or down? Down. Because of the minus, it opens down, right? The last term, as we saw, when we didn't have an x term, this last term here, that is the y-intercept. So just looking at it in standard form, you know those two things. Up or down, what's the y-intercept? Right? The y-intercept is -7. Okay, then we've got to calculate the vertex using the formula negative b over 2a. Okay, so here I go. Negative b divided by 2a. The b is 12, right? This is the b. That's where I get this 12 here. The negative is part of the formula. The a is -2. Right? So it's -12 divided by 2 times -2. That's -12 divided by -4, which is +3. Okay, so that's going to be the x-coordinate of the vertex. Now, how do you find the y-coordinate? You've got to go back up into this equation right here and put 3, right? Put a 3 there, put a 3 there, and calculate, which is what I'm doing here. -2 times 3 squared plus 12 times 3 minus 7 equals 11. So that's the y-coordinate. So now we know this is a parabola that opens down, and the vertex is 3, 11. Right? So I should go to 3, 11, which will put it about right here. Now we know that a parabola is symmetric. It's the same on one side as the other. So we actually introduced this term yesterday. So we would know that it has a line of symmetry, which actually we call the axis of symmetry, goes right through the vertex. And then so graph the vertex, the y-intercept, and the axis of symmetry. So we said the y-intercept was -7, and the vertex is there. Now, I'm calling this the corresponding point, but if there's a point which is 3 to the left of the axis of symmetry, right? Then there's got to be a point which is 3 to the right, so I can automatically make a dot there. And with those 3 points, can you kind of see where the U is going to go? If I connect these 3? Can't see. And the answer is yes. Of course, it will keep going. So these are the steps you want. First, you've got to calculate the vertex. And you know what the y-intercept is because it's right there. It's that constant term at the end. So you got to calculate the vertex, plot the y-intercept, and then use the symmetry of the parabola to find a corresponding point. With those 3 points, you should be able to see kind of where the graph goes. We won't have to use 5 points. 3 points would be enough. What's that? If it asks for the vertex and which is not always integers, they could be fractions. So they wouldn't show up in the table of values. And if you have to do the axis of symmetry, you kind of have to get it right. Yeah. I cannot hear you. Was it negative? Oh, you're right. That was a negative. I gotta be careful here so I don't erase. She's right as usual. So it actually was here, so the other point would have been here. And, oh, I got rid of that. So the 311 is still there. So, okay, now I've got to use these points. Okay, which, we could tell this should have been a stretch, which you always think of as getting skinnier. And that's okay, that looks a little skinnier than the last one. So let's try this again. Graph this function. So again, first, is it up or down? Because of the 3, it's up. So that's easy to know. What is the y-intercept? 2. Okay. And now we got to calculate the x-coordinate of the vertex. Negative b divided by 2a. Right. What am I going to plug in here? Negative? Negative, negative 6. Remember, the b is negative, so it's got to be negative, negative. Over 2 times. What is the a? 3. Okay, so now we've got a 6 over 6, which is 1. Okay, so we got the x-coordinate of the vertex. Now let's find the y-coordinate of the vertex. We've got to plug in there. Right, y equals 3 times 1 squared minus 6 times 1 plus 2. So we're going to get 3 minus 6 plus 2 equals negative 1. So the vertex is positive 1. The square? What's 1 squared? No, the 3 is not being squared, right? It's the x is being squared. In this case, x is 1. Okay. So there's our vertex. So I need to come in here again. Plot the vertex. 1, negative 1. Put in the axis of symmetry. That goes right through the vertex. Okay. Plot the y-intercept, which we said was 2. And then plot a corresponding point, which if this point is 1 to the left of the axis of symmetry, then there should be a point which is 1 to the right. With those 3 points, does it look like we've got a parabola that opens up? Because that's what we said it has to do. Let me graph these, right? Like that. So there is the parabola. Okay, next one. Yeah, Connor. You think of it, let me know. Take a pass. So you're saying, do they have to have a y-intercept like other than 0? Is that kind of what you're saying? Could you have one that goes through the origin? Was that the question? I mean, yeah. What if this equation was y equals 3x squared minus 6x, and there was no constant term? That means it's 0. Right? kind of like a direct variation, right? Because it's just y equals kx and there's no constant being added, then it goes through the origin. So yeah, it could go through the origin, and it will sometimes. Okay, let's try this one. This is the last one. Do it, right? You try. Okay, do you get this far? Now, yeah, I've seen times when we get this far, we get the negative 12 divided by 2 times 3, and then we still don't get it right because we're trying to do just in the calculator negative 2, then we just say the divide sign, or negative 12 divide sign 2 times 3. That's not going to work unless you put this 2 times 3 in parentheses or use the fraction format. Right? What should this equal? It should be negative 2, right? Should be negative 2. If you didn't get negative 2, then it might be because you didn't do something right in the calculator. Now, if you get that point right there, I mean, could you just go to the calculator at that point and look up the y value? Yes, you can. Absolutely. You could graph or go to y equals and put in 3x squared plus 12x minus 1, and then look for what the y value is when x equals negative 2. But in the end, it will be y equals 3 times negative 2 squared plus 12 times negative 2 minus 1. Let's see, that's going to be 3 times 4 minus 24 minus 1, which is 12 minus 25, which is negative 13. So we have a vertex of negative 2, negative 13. So with that much information, I should be able to come over here. I should change my scale here. So I needed to go down negative 2, negative 4, negative 6, negative 8, negative 10. That'll get us far enough. And then I can go back to blue and a little bit fatter than that. Okay, so let's see. The y-intercept is negative 1. There we go. The vertex is negative 2, negative 13. About right there. All right, the axis of symmetry should go right through the vertex, so I can sketch that in. And then I use symmetry to find another point. Right? If there is a point 2 to the right of the axis of symmetry, there should be a point 2 to the left. And now with those 3 points, can we see the parabola, and does it open up like we said it would? Yeah, it does. So that's good. Kind of hard to draw that nice U shape going through, but do what you can. So that is it. That is the homework. We're done. We just have a little bit to add tomorrow and a quiz.